Yeah, I have a couple of, I'm thinking of a number type problems that are a little more similar to the ones that will be on the test. I think the ones I've been doing so far for the videos are more straightforward for folks. These have a couple of the features that have been tripping up some of you. So I've got them here on the screen. The digits of a 2-digit number add up to 5. If you reverse the digits and triple the number, you are now 37 more than the original number. What was the original number? I invite you to pause the video and see if you can come up with a setup for this and even come up with the original number. So, assuming you've paused, and you've come back now, I will walk through my setup for this one. So the first thing is I'm going to set x as tens place and y as ones place, and x plus y are the digits, and they add up to 5. So I have my first equation. My second equation requires me to have a way to express my number itself. So my original number is the tens place is 10 times whatever x is as a digit plus 1 times whatever y is. So that's my original number. So if I want to reverse the digits, that's going to be y is now going to be my tens place. So 10y plus 1x is my reverse digit number. All right. I'm going to express that as 1x plus 10y. And the only reason I'm doing it that way is because it'll keep my x and y in the same order, and that'll just be a little easier for the calculations. So the situation, though, is now I've got, this is my original number. Okay. And this is my reversed digits version of the number. And then I also need to have a 3 times my reverse digits version because I have to reverse the digits and triple the number. So that's 3 times one of these expressions. I'm going to use this one because it keeps the x and the y in the same order. So 3 times 1x plus 10y. You don't have to put the 1 there. I'm doing it to remind you that that is the ones place. Okay, so I know that if I triple the reverse of the number, and I'm going to be 37 more than the original number, which is 10x plus 1y. So I'm going to express that one here, 10x plus 1y. And the difference between those is 37. All right, so this is a complicated looking deal, but we can simplify it. And I'll go ahead and start simplifying it, which is your next step to solving the whole thing. So I have to distribute the 3. So I'm going to end up with 3x plus 30y. And then the other part, I'm going to go ahead and drop the parentheses, minus 10x minus 1y equals 37. Now, I'm going to combine all my like terms. This is the same as saying plus negative 10x. So I'm going to end up with negative 7x when I put 3x and negative 10x together. And then I've got 30y and 1y. So that's going to be plus 29y. And that's going to equal 37. Pretty ugly looking equation. This is definitely a situation where I'm going to be inclined to substitute. So I can rewrite this equation. If I subtract x from both sides, I end up with y equals 5 minus x. If I instead subtract y from both sides, I end up with x equals 5 minus y. So I've got two versions. I've got two versions of the equation, one in which x is expressed as 5 minus y, and one where y is expressed as 5 minus x. And I can take those expressions and I can replace one of these. I'm going to prefer to do multiplication times negative 7 over 29. So I'm going to replace x with 5 minus y. At any point in this video, it's a good idea to pause and try and work it out yourself, and then see what I did. So I'm going to replace x with that. Not sure what it did there, but I'm replacing x with that. I've got plus 29y equals 37. So negative 7 times 5 is negative 35. And then negative 7 times negative y is plus 7y. Don't lose track of those negatives. Plus 29y equals 37. Okay. I'm going to add 37 to both 35 to both sides to get rid of negative 35. And I'm going to end up with 7y plus 29y equals 37 plus 35 is going to be 72. I'm going to combine my like terms. 7y plus 29y is going to be 36y. That equals 72. So I'm going to divide both sides by 36. And 72 is twice 36, so y equals 2. So now I have my ones place of my number. All right, so if we go back to our original situation, I know that now that y equals 2, so I can go back here and figure out what x is. So x is going to be 5 minus 2, because y is 2, so x has to equal 3. So my number has to be my original number has to be 32. And there you have that first one. So you should pause the video and see if you can set up the second one here, which is the digits of a two-digit number add up to 14. If you reverse the digits and double the number, you get your doubled number is now 131 more than the original number. What was the original number? Please pause this and see if you can sort this one out. Okay, assuming you've paused, I'll do my setup. So once again, I know that my first number, I'm going to actually go back and borrow stuff here. My first number and my second number, I can just grab those and express them that way. Okay, so my first number is just 10x plus 1y. My reverse number is 10y plus 1x, because now my ones place has become my tens place, and my tens place has become my ones place. I'm going to reverse them again to keep them in the same order. I know that my tens place plus my ones place digits add up to 14, so I've got that equation. So I can set that aside. And now I need to deal with the other equation. So I know that I've got something that I've got one version, that's something that's 131 more than the other. Okay, I'm going to go and do this so I don't keep going off the page. Okay, so I've got a subtraction problem. I've got to double my reverse number minus my original number, and that's going to equal 131. All right, so that's what it says. I've doubled my number, I reverse the digits, I double the number I got, and now I'm 131 more than my original number. So let's go ahead and replace this with the expressions for the two numbers. Here's my original number. And here is my reverse number. My reverse number is 1x plus 10y. I'm just going to type it in because it seems to want to jump around on the screen. If I copy and paste. And so here I have double of my reverse number minus my original number equals 131. So I have my setup. Pause the video and see if you can figure out what the answer actually is. Assuming you're back from pausing, let's go ahead and simplify this equation. We're going to distribute the 2. That's the first thing we need to do. 2 times 1x is 2x, plus 2 times 10y is 20y, and that's going to be minus, I don't have anything to distribute except the negative 10x minus 1y, all equals 131. And now I've got like terms to combine. 2x minus 10x is going to be negative 8x. And 20y minus y is going to be 19y. And that equals 131. Again, this is a situation where I would use substitution. And I'm going to rewrite this equation. If I subtract x from both sides, I get y equals 14 minus x. If I subtract y from both sides, I'm left with x equals 14 minus x. So I have different versions I can work with. Again, I'm going to prefer to multiply times negative 8 than times 19. So I'm going to figure out, I'm going to replace x with the expression for x, which is 14 minus y. And some of you probably noticed I had a typo. I have just fixed it. So I've got 14 minus y. And now I've got an equation that's all in one variable. And one variable we can solve for. So negative 8 times 14. Okay, well, let's work that out. We know it's going to be negative. So 8 times 4 is 32. And 8 times 10 is going to be 80. So 80 plus 32 is going to be 11. So 80 plus 32 is going to be 112. It's negative, so we leave the negative there. Now, negative 8 times negative y is actually going to be positive 8y, and that's all plus 19y, and that equals 131. Now, in this case, I'm going to combine my like terms first. I can do either one. It doesn't matter which I do first. So 8y plus 19y is going to be 27y. And that equals 131. I'm going to add 112 to both sides to get rid of negative 112. And so now 27y equals 131 plus 112. All right. 2 plus 1 is going to be 3. 3 plus 1 is going to be 4. And 1 plus 1 is going to be 2. Some of you may already know this, that 243 is going to be 3 times 81, or 9 times 27. So I'm going to divide both sides by 27. And y will equal 9. 9 times 27 equals 243. You can check this out. 9 times 7 is 63. 9 times 20 is 180. 180 plus 63 is 243. So I now have my y digit. That's the ones place, is 9. So something 9. All right, since we know that, we can figure out what our tens place digit is. Our tens place digit is 14 minus our y, which is 9. So 14 minus 9 is 5. So our original number, which is 10x plus 1y, is 10 times 5, or 50, plus 1 times y, 0.49. So 59 is our original number. And we're done.